Yo, what is up YouTube? In this video we're going to try and find the general solution to this system of differential equations. And I'm going to tell you right off the bat we get complex eigenvalues. So let's go ahead and set this up. So our matrix A is going to be equal to 7, -1, 5, 3. And taking the trace gives us 10. Taking the determinant equals 21 plus 5 is 26. And we get opposite, or not opposite of tau plus or minus the square root of tau squared 100 minus 4 times the determinant 26 all over 2, and we get 5 plus or minus I. So alpha for our general form is equal to 5, and our beta is equal to 1. Awesome. Next step here is to find the eigenvalues that correspond with our eigenvalues. So eigenvector corresponding with the eigenvalue, we get, let's start off with the plus version where lambda equals 5 plus I. We use the general formula that a times a vector equals lambda times that vector. So a is equal to 7, -1, 5, 3. V is what we're solving for, so we do V1, V2. And this is equal to V1 times 5 plus I and V2 times 5 plus I. So we do the matrix multiplication of the top row, and what we get is 7V1 minus V2 is equal to 5V1 plus V1I. So we rearrange, we get V2 equals 2V1 minus V1I, or V2 equals V1 times 2 minus I. Therefore, we can write an eigenvector where V1 is equal to 1, and we choose that, and then V2 would then be 2 minus I. And this is the eigenvector that corresponds with the eigenvalue 5 plus I. Next, we know that our complex conjugate is going to get an eigenvector 2 plus I. So 5 minus I yields 2 plus I. Now we're going to break these down into terms for our beta, or our A and B vectors, so real and unreal parts, or imaginary parts, complex. So with this vector we have 1 and 2 minus I. This is going to be equivalent to 1, 2 plus -1 times I. And then same thing with the other one. It's going to be 1, 2 plus I is equivalent to 1, 2 minus the quantity 0, -1 I. So here we can quickly identify what our A and B vectors are. Our A vector equals 1, 2. Our B vector equals 0, -1. And since we know our alpha equals 5 and our beta equals 1, we can write out our full solution as C1 e to the alpha t, so 5t, times the quantity of our A vector, which is 1, 2, times cosine of beta t. Beta is 1, so it's just t. And then we subtract our B vector, 0, -1, times sine of t. And then we add C2 e to the alpha t, 5t, times our A vector again, 1, 2, sine of, instead of t, it's still going to be t. And then instead of minus, it's going to be plus. And then our B vector, 0, -1, times cosine of t. And that gives us our final answer for this question. Awesome.